Hello everyone, welcome back. We are looking at Section 1 topics in additional mathematics, and in this lesson we are going to be looking at geometric sequences. We have three objectives: to introduce geometric sequences, to differentiate between geometric and arithmetic sequences, and to solve problems involving geometric sequences. So let us introduce geometric sequences and say exactly what they are. A sequence is geometric if each term in the sequence is found by multiplying the previous term by a number r, so that an plus 1, the next term, is equal to r times an, which is the current term that you have. The r is what we call the common ratio, and we find it by dividing an plus 1 divided by an, which is the next term divided by the previous term. The nth term of a geometric sequence, that is the general form of it, an is equal to a1, which is the first term, times the common ratio raised to the n minus 1. This is the general form of it. Now let's try to put some of this information to use. Here we have in this table the results of an investment. So you have $2,000 in an account with a fixed interest rate of 8% per year. The amount of money in the account at the end of each year using compound interest is shown in the table below. Is the sequence of monies earned arithmetic or geometric? So how do we differentiate between an arithmetic sequence and a geometric sequence? If a sequence is arithmetic, it has what we call a common difference. And what the common difference is that you take consecutive pairs of terms and you subtract them. And if you subtract them and you get the same number, that common difference, then it is an arithmetic sequence. So let's check if this is arithmetic. So we'll take this pair of terms first, 2160 and minus 2000 from it. When we do that, we get 160. Now if we try to the next pair of terms, 2332.80 minus 2160, you will realize immediately that these two are not the same. So these two numbers are not the same, which tells us that it does not have a common difference. So this is definitely not arithmetic. Now, if it is geometric, it has what we call a common ratio. Now, how do we find the common ratio? We find the common ratio by dividing consecutive pairs of terms. So we take 2160 and we divide it by 2000. Once you do that division by punching it into your calculator, you get 1.08. Taking the other pair of terms, 2160 and 2332.8, 2332.8 divided by 2160, and of course, when you punch that in again, you're going to get the same number, 1.08. So this sequence of numbers has what we call a common ratio. And because it has a common ratio, we can say that it is geometric. So the sequence of monies is geometric. Here we have two sequences of numbers. Are they geometric or not? And to test if they are geometric, what we do is that we use the formula ratio. Common ratio is equal to the an plus 1 term divided by an. That is, using this pair of terms, we're going to say 8 divided by 4. Or you want to use another pair of terms, 64 divided by 32. Notice that in both instances, we get the same number. So it has passed this test in given that it has a common ratio, and because it has a common ratio, it is geometric. So this one is geometric. Let's try on this one. Using the same idea, 6 divided by 3, we end up with 2. Now 9 divided by 6, we end up with 1.5. So we realize that we do not have a common ratio for this one. So this one is not geometric. This one is actually arithmetic. And if we take the numbers and do the arithmetic test on it by subtracting. So 6 take away 3, we end up with 3. 9 take away 6, we end up with 3. We realize that this sequence, has what we call a common difference. And because it has a common difference, we call it an arithmetic sequence. Now let's spend some time looking at the common ratio of a geometric sequence. Remember, we find the common ratio by dividing two consecutive terms. So here in this one, we have 5, 20, 80, and 320. Let's pick this one, these two consecutive terms. So 20 divided by 5, and that would simply give us 4, and that would be our common ratio. If you want to try it with another pair of terms, then 80 divided by 20, notice that we get the same 4. It is our common ratio, and this sequence is geometric. Here we have these two terms, so we're going to divide a negative a half divided by 1, and doing this division, of course, we're going to get negative a half, which is our r. So this is our r in this question. And in this one, C, using this pair of terms, 5,500 divided by 5,000, punching that into your calculator, we end up with 1.1. And this is our r in this instance. So to find the common ratio, pretty simple to do. All that we do is that we take two consecutive terms and divide them. And once you divide them, we end up with our r, our common ratio. Here in this question, we have a geometric sequence where our first term is 1 and our fifth term is 16. We want to find A9. To find A9, we must first find the general form of the sequence, which is AN is equal to A1 r to the n minus 1. So once we can write our sequence in this way, we can find the ninth term. Now, our A1, our first term is 1, and our fifth term is 16. So we can write that out. A5, which is the fifth term, is going to be equal to A1, which is 1, times r, we don't know what r is, r to the n minus 1, which is 5 minus 1. And of course, we are told that this is 16, A5 is 16. So we have an equation here that simply says r to the fourth is equal to 16. And in solving this, we end up with r is equal to 2. We can take the fourth root by saying r is equal to 16 raised to the 1 over 4. Or if you want to write it this way, then we get r is equal to 2. And once we know that r is 2, then we can plug our information here and say that an is equal to 1 times 2 to the n minus 1. That is, this one can be simplified a little more since we're dealing with 1 here. An would simply be equal to 2 to the n minus 1. And so A9, which we wanted to find, would simply be 2 to the 9 minus 1, which means 2 to the 8. And that's our answer right there. Of course, you could punch that in your calculator and work it out. 2 to the 8 turns out to be 256. But this is your answer. Moving on to our next question. What is the 10th term of the geometric sequence 0.25, half, 1, etc.? It's going up. So we know this, and so we can write this down as A1, but we need to find what the common ratio is. And remember, r is equal to an plus 1 divided by an. And so we can use these two terms, 0.5 divided by 0.25. And doing that division there tells us that r is 2. And so the general form of our sequence would be an is equal to 0.25 times 2 to the n minus 1. And once we know this, we can go ahead and work out the 10th term. So the 10th term, A10, is going to be 0.25 times 2 to the 10 minus 1, which is the same thing as 1 over 4, or 1 over 4, times 2 to the 9th. And we can work this out by saying 1 over 2 square times 2 to the 9th, and punching that into your calculator or otherwise would give us 2 to the 7th, which is 128. Next question. Find the geometric sequence whose fourth term is 3 and whose common ratio is 1/3. So again, we need to find the general form of the sequence. an is equal to a1 times r to the n minus 1. We need to find this first. We know what the fourth term is. We know what the common ratio is. In this case, we do not know what a1 is, so we need to find a1. We have information that we can use to find it. The fourth term is 3, so we know that a4, which is going to be equal to a1 times the common ratio, 1/3 to the, let me just write that a little better, 1/3 to the 4 minus 1, which gives us 3. This is equal to 3. So a1 here is going to be equal to 3 divided by 1 over 3 raised to the third power. And that we can evaluate by saying a1 is equal to 3 divided by 1 over 27, which calculates to be 81. So knowing our a1, this is a1, we can now write down our sequence, which says an is equal to 81 times our common ratio, which is 1/3 to the n minus 1. So this is the geometric sequence that is being discussed here in this question. Find the a1 term using this information and write it down. Find the geometric sequence whose fourth term is 3 and whose common ratio is 1/3, and this would be it.